Hey guys, this is the last video for 13.1 through 13.2 for the week while we have school closed. And what we're going to be doing is taking degree measurements and trying to turn them into radians, and taking radian measurements and trying to turn them into degrees. So a couple things that we want to deal with. Okay, first off is recognizing that there's a degree symbol here. The relationship that we use to make conversions is that pi radians is equal to 180 degrees. Now, just like you would convert inches to feet or meters to centimeters, we're going to multiply by a fraction every time. Now, we did this in class. Maybe we talked about it a little bit differently when we were in front of each other. So I'm going to give you the really formal way to do it. And then if you remember, oh yeah, I remember doing this, there's a little shortcut here or there, you're welcome to do it. But what we're going to do is we're going to times by a fraction in both situations, okay? The fraction we times by is going to use pi and 180 degrees. That's our conversion factor, so that's the fraction that we'll always use. The difference is in one part, pi will be on top. On the other part, pi will be on bottom. And so what we're going to do in the first one, notice that we have a degree symbol here. We want to get rid of that degree symbol, so we're going to put 180 degrees on bottom. That allows me to cancel the degree unit and leave myself with something else. And here we have pi. So whenever we want to go from degrees to radians, we're going to put pi over 180. Now the way this is actually going to look is 300 over 180 with a pi. What we want to do is we want to simplify 300 over 180. Now, if you have a fancy calculator like the ones we used in class, obviously we have that math frac option. If not, we need to find a fraction reducer. You can look for one online, or we can just remember some of our general rules. These are both divisible by 10 because they both end in a 0. So I'm going to get rid of the last 0 and make this, sorry, I got a little blurry here, make it 30 over 18. Again, I still have my pi there. And then I look at 30 and 18 and I divide them by something that they have in common. In this problem, it looks like 6 is my best option. But if you guys divided by 2 and got 15 over 9, maybe then you'd see that they're divisible by 3 and divide that off. Either way, if we divide these by 6 to reduce, we should get 5. And now I'm going to put the pi with the 5 over 18 divided by 6 is 3. And we have 5 pi over 3. Now that is also one of the numbers that shows up on the unit circle. So if you still have your unit circle, if you had gone and looked at 300 degrees, you would have noticed the 5 pi over 3 right next to it. So that's one option, okay? Reducing by hand is the other option. So that's if we want to go to degrees to radians, we use pi over 180. So now, to do that in the opposite way, instead of canceling the degree symbol, we want to cancel the pi. And so we're going to put 180 degrees over pi. It's going to allow me to cancel pi for pi. And then when it comes to multiplying this, we literally just take 6 times 180 and divide by 5. At this point, maybe you're like, oh, Mr. Welch, I'm not that good with numbers. Can we use a calculator? You could technically use a calculator this whole time. I don't know that Desmos is going to give you reduced fractions. Like if I take, earlier we had 300 divided by 180. I don't want this 1.6666 repeating. Like that's not what we want. You'd have to convert that back into a fraction. Now, obviously, you can Google that. There's lots of ways to do it. Wolfram Alpha, I'll write that down here in just a second. It's a good place to go if you're really struggling with stuff like this. It can help you with that. But what I had on my problem here was 6 times 180, and I need to divide that by 5. The order in this doesn't really matter. If it bothers you, you just kind of come back here. I'm going to get rid of that 6, go up here into the fraction, do 6 times 180. Turns out to be 216, which means when I come back here, my answer is 216 degrees. Okay, so let me real quick, I'll show you that website. Um, Wolfram Alpha is good for a lot of things. What it's not good for, um, is replacing um, general understanding of what's really going on. So for instance, if I take 300 and I divide it by 180, okay, and I hit enter, it's going to give me a lot of different options. Here's a decimal approximation. There's the exact result. There's that reduced fraction, 5/3. So whatever method you want to do, but those are the two different types of problems that we're doing today, going from degrees to radians and radians to degrees. All right, good luck, and shoot me some questions.